Are there any questions on the first session? Probably you can probably you can ask right now. Okay, I forgot something which I usually do in terms of starting the new batches. So I think we need to introduce our each other, because this is the master level course, and we may have the opportunity to learn from the peers which are working usually work for industry, and it's not a kind of the lecturer centric in terms of master's level. Sometimes there are situations or advantage we can learn from the peers as well. Shall I start the process right now? I will tell you the name. Just introduce yourself if possible. Okay, let me start with Lakshi Kumanayaka. Would you mind unmute and introduce yourself, please? Lakshya, are you there? All right, let me go to the second one. Takura Ramavikrama, would you mind unmute and introduce yourself? Seems to be nobody's preferred to unmute. So let me go to the third one. Mahesh Hevavasam. Lakshi, you are there.
Yes,
right?
sir. Yeah, sorry, sir. I'm Lakshi Kumanayaka. I'm from Matara.
Can you hear me?
I'm working at Bank of Ceylon.
Can I start, please?
Can you hear me, sir? Hello. Can you hear me, sir?
Okay,
Hello?
Takura, you unmuted as well. Would you mind introducing?
Yes, sir. Sir, I'm Takura Ramavikrama. Currently, I'm working at Civil Aviation Authority of Sri Lanka as a manager ICT.
I can't hear any of you. Mahesh, probably you can try. Hevavasam.
Sir, can you hear me?
Okay,
Sir, can you hear
hope
us?
others can hear what they're telling, right? Only thing is I don't. Okay, just give me a second. All right, it's something in terms of my speakers, I guess. All right, let's do the exercise on the other day, third session, because it seems to be there's something wrong in terms of my speaker functionality, because I have been using this new mic because the previous students wanted to more clarity on the mic. So I need to check this and come back to you on the next day. All right, let's start the introduction on the next week, on the second week. Right, thank you. Let me start the Okay, hope you can hear me at least from my end. Can somebody confirm? All right,
Yes, sir, we
let me
can.
start. All right, on the session 2, we'll be starting on the network troubleshooting approaches and the troubleshooting fundamentals. This is something in terms of usually troubleshooting considered as a trial and error process, but there are fundamentals here as well, because if you follow the fundamentals, understand the fundamentals and follow the best practices in terms of troubleshooting approaches, it may be quite effective in terms of reduction of time, the resolution time, and maintaining your stability of your network systems. And all those are important to understand the troubleshooting approaches and the fundamentals further. This is a course of an academic setup, which you are learning from the University of Colombo, and which is an academic institute. So we are mostly interested in terms of learning academic aspects, whatever the subject we are learning here, and we are further adding the best practices and the industrial practices as well. But the important aspect here in terms of masters in cybersecurity courses, we are first learning the academic aspect, and then the matching with the practices. So we should learn that's the importance of learning network troubleshooting approaches and the troubleshooting fundamentals. Okay, let's go to the next slide. Okay, this is the agenda for the session 2. On the session 1, we covered the basic introduction with the definitions, and we discussed in detail about the network lifecycle, modern secure network. So then on this session, the next session, we will be covering network troubleshooting approaches, troubleshooting fundamentals in 4 different segments, and again on the failure modeling will be discussed as well. Initially, most of these ideas, the fundamentals are applied to all the network systems. For an example, we can categorize networks as campus networks, what we defined previously, and the data center networks, and the wide area network, and cloud networks. And there can be various networking implementations, or the purpose of the application requirements. So basically, this covers the idea, so the concept mainly on the enterprise campus, and as well as the data center networks. Some of these fundamentals applied for cloud networks as well, and the wide area networks, and the service and service provider networks are out of scope in terms of this particular course. The cloud networking we'll be discussing on as an emerging technology on the last lecture. So, but mainly covering the enterprise campus networks, and as well as the data center networks, and the cloud networks. So that's the scope in terms of the course module. Okay, network troubleshooting approaches. There are 2 main troubleshooting approaches. If you have followed the design course previously, you can recall that these 2 approaches are there for the design as well. But design only limited to these 2 approaches, but troubleshooting approaches have more than this top-down and bottom-up approach. The first couple of common approaches to analyze and troubleshoot networks, the first one is top-down approach, the second one is bottom-up approach. There are 6 of them, but these are the first 2, which is somewhat similar to your design approaches. Okay, that what the top means from where to where, it's kind of a, you need to find a reference point, right? You can recall, I think, in the previous courses, so the course modules related to networking covered on OSI model, OSI Open System Interconnection model, which is having the 7 layers. From physical layer, the most bottom layer is physical layer, and the most top layer is application. And this physical, if something your troubleshooting start from the application layer and going below the OSI model, that's we usually call top-down approach. So you are starting from the application layer and moving down each layer to the up to the physical layer. That's called top-down. Similarly, the bottom-up approach is quite opposite. You are starting from the physical layer and moving towards the most top application layer. So those are the differences, but let's discuss why you are selecting sometimes this top-down approach, or why you are selecting bottom-up in certain cases, because it's based on the nature of the issue you are troubleshooting. So let's see the top-down approach. The top-down troubleshooting method, as I mentioned, it's using the OSI model as the guiding principle. So not always the case for other approaches, but top-down and bottom-up, it's a reference point is OSI model. One of the most important characteristics of the OSI model is that each layer depends on underlying layers of its operation, which means each and every layer having its own function, own operation. So you are starting with the application function and the operation. This implies that if you find a layer to be operational, you can safely assume that all underlying layers are fully operational as well. So basically, the assumption is if most top layer is working fine, and usually the bottom layer should be work fine. If the entire 7 layers should work well in terms of the systems to be function, network system to be function. So let's go for an example. So these examples are quite important because these can be tested on your final examination. You can check previous exam paper, the past papers as well. These are common questions sometimes tested on your final examinations, and your assignments will be there. And this is an example. Let's say you are connected, there is a server, and there is an end user. One of your application which is running through the TCP, and the server application hosted to communicate outside with the port number 80 on the transport layer. And the network is IP network providing redundant data path between client and workstation. The quite reliable network with a redundant data paths. No single point of failure, we can assume. The user is connecting through to the network and accessing the application, which is TCP application, which is with the port number 80. And the issue or the symptom of the issue is the user complaining that he cannot open a particular website on a particular server, which is hosted on this server. So intranet website, is typing the URL but unable to connect to the particular server with a HTTP request. Now, this is what he's troubleshooting. This is the scenario of application layer failure, because you are directly accessing the application, and you are getting a request. You are unable to connect to the hosted application by using the application port number, which is port number 80. In this case, it's quite obvious you need to start from the application layer to the bottom layers. So there are several ways. Even though your URL not possible to, we are not discussing the solutions here. We are just discussing the troubleshooting approach from where to start. So you definitely need to start from the port number 80. Probably there are several tools which we can discuss. There's something called MyTraceRoute MTR, which you can send. For an example, if you want to troubleshoot this particular thing without considering whether you just want to find out if it is an something like real application hosting application layer issue, or if it is something below. That's the first thing you need to start checking. Probably you can use another application which can be deployed between the server and the client. For an example, you got a trouble ticket from this particular user, and now you are at the troubleshooting stage as a network systems administrator or network administrator. So where you decided to start from the application layer, because the user just said he's having application TCP application with port number 80 and unable to connect with the server. So you have you have several cases to several things to consider. You don't know whether other users are capable of accessing this particular server with this without having. So in that case, there can be issue on this particular end host or the client. There can be situations you are having all the users are impacting and the server side having issue. So irrespective of thinking all other hypotheses, you started thinking just to troubleshoot this particular trouble ticket only received from user. You are not going to check whether the others having an issue. So you decided to start from the application layer, and you have access to both the server and the client. So you decided to test a different application, implement different applications, something like MyTraceRoute, and you are implementing you are using MyTraceRoute tool to check whether, or you can there can be another tool like Telnet. You can Telnet with the port number 80, and if it is not connecting, you can start from there. If it is, that means server is not responding to the port number 80. And then you are going to the server and start start troubleshooting further on the server side. Something like starting from the application layer, either by Telnet or by using MyTraceRoute tool, that's the approach of starting from the application layer, because you are working from the application port number from the application layer of the OSI model. All right, let's go to the next one. Then you will get understanding on the other approach. For an example, let's move to the bottom-up approach. Now, the bottom-up is you are starting from the physical layer. The bottom-up troubleshooting approach also uses OSI model as the reference and the guiding principle, the physical most bottom layer of the OSI layer as the starting point. This approach, you work your way layer by layer up towards the application layer and verifying the relevant network elements are operating for each layer or number of layers. You try to eliminate more and more potential problem causes to narrow down so that you can scope the potential problems, because your starting point sometimes matter to the quick resolution. If it is closer to the if it is a first line, if it is at the application layer, you can resolve it immediately by using top down. If it is at the presentation or session layer or transport, then you can quickly move to the next layer from the application. But if you started from the bottom up, if you're having application layer, then you need to take more time. So it's a gut feeling where you can start sometimes, but this is kind of a explaining the method or approach we are using on the bottom up. Okay, this is another example, somewhat similar to the for the bottom up approach. Let's assume that you are researching a problem of a user that cannot browse a particular website. While you are verifying the problem, you find out the user's workstation is not even able to obtain IP address from the DHCP process. On the previous one, you had the data only from the user with the trouble ticket saying that you can't just open the website of hosted on internet website hosted on a particular server. That's the only data point. Now this one having more data. So you started troubleshooting as a network administrator with this trouble description. You find out or you went to the user's workstation and with checking IP config, you notice that there is no IP on the DHCP IP received from the DHCP server, which is auto IP assignment service, dynamic host configuration protocol server, usually giving IP addresses when automatically giving IP addresses to the clients, which you don't have to have configure the private IPs manually. But when you even with the same description with the more details, you notice that no IP address of the even it's not the web access issue, it's which is but you have additional information with starting the troubleshooting. You notice that client doesn't have an IP address. It's on own client computer leased by the DHCP. So it's you can in this situation it is reasonable to suspect lower layers of OSI model and take bottom-up approach rather than you start from the application layer by using top-down is not necessary here because you take more, you know that the bottom layer should work to top layers to operate. So now you need to resolve you need to start checking why this particular machine or particular client host are not getting an IP and start from the bottom. Probably there can be a cabling issue which hasn't connected for long some time or he's coming back after the weekend and somebody has done a cable swapping or something like that. Probably you can start from the physical layer. So if you are starting something with the cabling, then we can assume that that's starting from the physical layer. If you are starting the troubleshooting from the application port or application, then that's we can call top-down approach. So it's your gut feeling, and based on the available information, you can decide where to start. For an example, the first example, only having information on the user cannot access the web server, but you have more information on the second example, which is not having DHCP provided IP address, and you can start from the bottom is the better approach. So based on the details you are having, you can decide whether you start from the top down or bottom up. Are there any questions until this point? All right. Okay, let's go to another approach, which is it's not an approach, it's not an approach which is available on your design courses. Design courses, you are usually having top-down and a bottom-up approach on the different contexts. Usually, when you are designing a network, it's better approach is to design the network based on your application requirements. As we discussed on the life cycle model, you need to first prepare and plan with the with the other stakeholders or business stakeholders to understand the business requirement and the application requirement, and you are building the network based on the business requirement and the application requirement. So that's kind of a top-down design when you're designing the network, but that's a much better approach in terms of designing the network. But if you don't have sufficient time to design and address all those business constraints, and you have a limited time, let's say the new startup, and the business team wanted your network yesterday, and you have to deliver it within few days, and you don't have time to do all the POCs and go through the design processes. So there is a time constraint on the project. So in that case, you can use bottom-up approach for the designing. That's where you can design based on your past experience. You know that a number of switches, and you can decide based on your rule of thumb, and you know that application layer, the 3-tier architecture and the core layer switches, distribution and access layer, what are the norms, and you just build the network for any general application, not for specific applications. So if you are in hurry to deploy, you can follow that, but it's not the most optimal way, because there can be application issues that may impact businesses. But it's a most generic way of designing the network. Most of the time, most of the system integration organizations, if they don't have time, they go ahead with the bottom-up approach rather than designing for the applications. So, but in this case, troubleshooting, it's quite different. You already have a network with deployed, and you are where this defines only where you start the troubleshooting based on the OSI model. Now, if you have now third approach, again, it's a reference to the OSI model. That's called divide and conquer troubleshooting approach. Divide and conquer troubleshooting approach strikes a balance between top-down and bottom-up troubleshooting approaches. Usually, the advantage of this method is that you can quickly decide on the scope of the problem and whether escalation is necessary, top or down. Because you can start from the middle intermediate layer and move up or down, move up or down based on the tools you are having. So that's something you can use as well. This is an example of that. The divide and conquer, usually, let's assume that you are reaching a problem of user who cannot browse a particular website, again, as the case on the previous two issues, particular website, but you have more information, and that while you are verifying the problem, you find out that the user's workstation can successfully ping the server IP address. Usually when we talk to the system administrators or open a trouble ticket, they usually ask from us, have you tried to ping the remote IP address? So the ping, they will give you an IP address to ping and return with the results. So in this case, initially you can user complaint that open a ticket saying that the internet web server unable to access, but he has additional information. He just tried to ping the server IP address because he has that information with him. So ping was successful as well. So now you have additional information. So you just decided to you can decide start troubleshooting with certain assumptions, because the ping application works based on the protocol name ICMP, right? So this ICMP is the protocol of the transport layer. So now that's the beauty of this application. Now you are quite capable of pinging. It means that physical layer is functioning well, the bottom layers are doing well, which means physical data link network layers are working well, including the transport layer. Now you need to work on top of other layers for the troubleshooting. So the troubleshooting direction decided in terms of OSI reference. So that's the main idea in terms of divide and conquer troubleshooting. You can decide the previous approaches having only one direction, because you are starting from the top to down, which is from the application to the bottom, and the bottom up approach starting from the physical to the top, and the divide and conquer having, you can decide on the two directions. So let's assume that ping has failed, then you need to go direction decided to go down to check on the physical layer, data link layer, and the network layer, cabling, and all other protocols. Okay, that's the in this situation, it is reasonable to assume that physical data link and network layers are OSI model are in good working conditions, and so you examine upper layers starting from the transport layer in a bottom-up approach. So these are the three main troubleshooting approaches, reference to this thing, what's called OSI model, Open System Interconnection. Right, so these are the three major models which are usually the best practices in terms of understanding the troubleshooting for the simple cases. But there are other three models which is somewhat advanced in terms of the usage can be mostly for the network engineers, system engineers, and as well as for the advanced troubleshooting. There is something called follow the path troubleshooting approach. So in the previous three, usually we considered in terms of the communication between source and destination. In this case, you are not concerned only the source and destination. Maybe your troubleshooting approach may go beyond that, and checking the path in between that, or the devices within the path in between source and destination are considered here. This follow the path approach is one of the most basic troubleshooting techniques, and it's usually complements one of the other troubleshooting methods such as top down or bottom up. So it can be included as subset included for the top down or bottom up approaches based on its tool usage. So in this case, the follow the path approach first discovers the actual traffic path all the way from source to destination. Next, the scope of which means there can be multiple paths between source and destination. You need to find out the exact path your application failure happened by using a way of troubleshooting. The scope of troubleshooting is reduced to just the links and devices that are actually in the forwarding path. So then not only you are worried on the path, you are concerned in terms of devices within the path, intermediary devices. And the principle of this approach is to eliminate the links and dividers that are irrelevant to the troubleshooting task at hand. For an example, there can be multiple paths between source and destination, but you need to omit alternative paths. Just need to troubleshoot the exact path. There can be multiple networking devices and paths within your network, but you need to find out the exact path, traveling path between source and destination, which your incident happened. Not other equipment. So this is kind of an isolation of all those things and finding troubleshooting on the exact path. All right. So this is somewhat specific, even though it's a basic tool which we are using, something called traceroute. Usually we test only the ping to check the communication between source and destination. But in this case, we are doing extensive troubleshooting of the entire path and its the real application path and its intermediary devices. So traceroute is another application, somewhat equivalent to the ping, but it's more advanced in terms of response. Now we are sending, if you run the traceroute, you are sending a packet from source to the destination. If you run the traceroute from the source, giving the IP address of destination. So now we are at the server, which is the sender, and the direction to the receiver side or destination side. So now it will send a packet to the destination with the TTL, time to live. There is within the TCP/IP stack, you have a field named TTL, time to live. You are giving number of layer 3 hops which is possible to travel by giving the TTL. If you give TTL time to live 1, this is just once it received your default gateway or the first layer 3 interface, it's expired and giving a response. It is again somewhat similar to the ping application. It's using the protocol name, control plane protocol name, ICMP. It's using the ICMP echo message to get a response. Once it's expired, once it hit the first default gateway or the first layer 3 hop, it's returning with the ICMP echo exceeded message, and you are getting a response from the first device, which is, you can confirm that your default gateway of L3 device is responsive. So now you can eliminate that first. It's not on the communication issue, not on the first on the L3 device or the default gateway. Now the application keep on sending. I'm just explaining you the iterative process. The first step is this. Then it's secondly, you don't have to do manually rerun the application again. But traceroute will automatically send with first packet with the TTL1. If it is received the response, then it will send the second one. Another message with the same destination IP address with the TTL2. So it can go up to the layer 3 devices, or after the gateway or the next router or the next layer 3 device will reach it. And if it is responded properly, Okay, likewise, between the source and destination, it will send multiple ICMP echo request and observing for ICMP echo exceed messages from TTL1 to TTL3 in this example. So all the if it is receiving final response from the destination IP address, then your path is quite cleared. And at least it's working for the layer 4, which is the transport layer, which ICMP is residing. All right, so this is kind of tracing the path. This is a follow the path troubleshooting approach, which you can use if you are troubleshooting the path in between. So this is mainly used in the advanced troubleshooting in terms of your network engineer wanted to verify the entire network path and its devices. You can run this application as well as user, but some of the devices, since there can be security issues, some of the ISPs and some of the enterprises are blocking this ICMP request. So sometimes these traceroute tool is not working as expected because it's blocked in the most of the security reasons based on security advisories, because this can be used to understand the network path and the devices of your enterprise network or the ISP network. So that's why this has disabled some of the organizations for the security reasons. But in this case, you can use another tool. There is something called MyTraceRoute, which you can use rather than using ICMP. You can use the TCP port, which is TCP port number 80 or whatever the application port number you are using to communicate with the remote remote server or remote client. You can use that MyTraceRoute tool by using just TCP port number. You don't have to depend on ICMP enablement. So that is a famous tool these days for troubleshooting, especially on the cloud communication and all those stuff. Since this is ICMP disabled on most of the enterprises or the organizations of the network devices to respond. So still you can use the follow the path troubleshooting method by using MyTraceRoute if you are not enabled for the traceroute for the troubleshooting. Okay, any questions on this point? Okay, let's take an example here. So bit of complex network. You have redundant path here. Let's assume that you are researching a problem of a user who cannot browse a particular website, and that web the same as before on the previous method approaches, the examples website, and that while you are verifying the problem, you find that the traceroute application on the Windows from the user's PC command prompt to the server's IP address succeeds only as far as first stop. It's going only up to the first stop because it's receiving only from the default gateway, which is the first IP address, first IP host from your client machine, which is the layer 3 switch, layer 3 or multi-layer switch. So you are only getting response from L3 switch B in this example. So the client, as you can see, the client, the user connected to a layer 2 switch, which is layer 2 switch X. So usually traceroute not sensible for layer 2 switches because it's only communicating, responding to application written as to respond get the response from the layer 3 devices. So it will automatically pass through the layer 2 device and hitting the layer 3 switch V, the switch identified as layer 3 switch V in this diagram, and it hitting the interface number 2, the link number 2, and then switch and responding well. But it's not going beyond that to reach the destination server. So that's the information we received on the trouble ticket, because user has run the trace route and just wanted to troubleshoot and updated the system administrator or network administrator based on the results he got. Based on your understanding of the network link bandwidth and the routing protocol used on this network, you mark the links on the best path between the user workstation and the server on the diagram with the number 1 to 7. You can say, because now your trouble ticket has gone to the network administrator. He knows the network devices in between the client and the server, and how it's configured and interconnected, and how it's interconnected and how the routing protocol is configured. And he has the guess in terms of his network understanding, where should this traffic goes through, on the which path. So now he can start the testing based on the trace route result provided by the user, because it's not going beyond the layer 2 layer 3 switch V, and he should test, he should check whether router number 3 or router number 1 is reachable from the layer 3 to layer 3 switch to the router 1 or router 3, and he can troubleshoot within the by the path based on the trace route report, which we can start from the layer 3 switch. The problem is beyond that. So that's one of the troubleshooting approach. If you have advanced knowledge in the network as well as the path troubleshooting, so it can be done by using this follow the path troubleshooting approach. Okay. Any questions on this approach or the previous troubleshooting approaches? Okay, let's go to the fourth one. The fifth one. We have already discussed 4 troubleshooting approaches: top down, bottom up, divide the conquer, follow the path. And now we are moving to the next troubleshooting approach. This is this is another troubleshooting approach which you can decide based on the time constraint and based on the information lag in terms of your operations. So this is something called compare configurations troubleshooting approach. So for this is something sometimes used heavily by, let's say, network administrators or the network engineers in their troubleshooting scope. Compare configurations troubleshooting approach is the name of it. Another common troubleshooting approach is called the compare configurations approach, also referred to as spotting the differences between approach. For an example, in this approach mainly used by the advanced users, not end users. If you have the configuration access for network devices, you can use this particular method, compare the configurations for the troubleshooting. If one network device is working fine, and similarly second device configured some similar to the device 1 config, if device 2 is not working, then you can compare the config directly rather than going into other troubleshooting methods and complications. You can just compare the configurations, working device and non-working device. So just need to match the working device configuration with the non-working device if it is configured equivalently. For an example, this is a branch office router configuration. So let's say you have a head office and there are several branches. All the branches connected to the head office by using these branch routers. The branch 1 and all other branches working fine, but branch 2 is not connecting to the head office router. So you can safely assume that branch 2 has some configuration or any other issue. The first start, rather than just replacing the device, you can start verifying the configurations. That easily can, rather than going through one by one on each configuration command or configuration segments, you can compare with a good working branch router configuration on good working conditions. So while comparing, because almost all are configured equivalently other than the IP addresses, those are the just differences. Configurations are same, but some of the IP addresses can be different for the branch office, but still the routes and all those things to the head office are same. We just compare the configurations. If there is an anomaly between the configurations, you can correct it immediately. That's one of the fastest resolution methods observed by network engineers as best practices. That is something well known. That's why it's mentioned as one of the most popular way of approach among the network engineers. By comparing configurations, software versions, which can be software version of router operating systems or router firmware can be compared, or the hardware module. There can be different hardware module, slightly different module, or you can compare the various aspects, not only configurations, for other device properties between working and non-working situations, and spotting the significant differences between them. This approach attempts to resolve the problem by changing the non-operational elements to the consistent with the working ones. So you are matching the working ones with the non-operational ones. If you can replace the change the configuration or upgrade the software or change the particular hardware subcomponent, or if any other device property is required to change. So that can be done just comparing if you have a large number of similar configurations with the network devices, only one is not working. This is an efficient way of troubleshooting to start. And there is a plus point in terms of faster resolution, but there is a weakness of this method as well. The weakness is that it might lead to working situation without clearly revealing the root cause of the problem. In some cases, you are not sure whether you have implemented a solution or workaround, because in disadvantage of this issue is you are not going for the advanced troubleshooting, just matching the config. You haven't went deep dive into the root cause and understood the issue on the future use cases or as a lessons learned. This is just a correction, but you just have no idea if it is related to any serious issue at the future. But since you have a time constraint or you have a serious pressure to resolve within a service level agreement, you can use this method. But it's not good for in terms of lessons learning aspect. So that is something important in terms of understanding. So so now we have discussed 5 different approaches: top down, bottom up, divide and conquer, follow the path, compare configurations. Are the 5 approaches, 5 popular approaches. The 6th one, the last one, we are discussing here, the swap the component troubleshooting approach. It is again somewhat similar to the previous one. If you don't have information, the previous case, at least you have advanced information. You have the configurations of the devices. But if you don't have much of information, and if your network administrator or the person who are who are assigned to troubleshoot is not available, probably you can try some of these options among you. This is not an option for advanced users, at least. The swap components sometimes work. Likewise, the famous saying that the always try to restart if you are getting an issue from your computer, then it is somewhat similar here, because you don't know the reason, but you are just restarting and sometimes it works. So this is something, swapping the component for the troubleshooting. For an example, in this case, there are a bunch of different devices, laptops, and as well as personal computers connecting to 5 devices connected to this particular switch. At least you know that you have the access to all these devices. Now your colleague on the laptop B informed you that all the other users are capable to communicate, but my laptop is not connecting to the network. So what you can do is you can talk to laptop user A and swap the bring his laptop and ask him to connect to the port, your Ethernet port on the desk. If it is working, the problem is on your the laptop, not the network connection. So you can contact the system administrator rather than the network administrator if those are 2 different personnel. So it's swapping the device is common method. You can just replace. Sometimes this is used by, for an example, if you know, if you are starting the trouble, you can start the troubleshooting process by just swapping device on these cases. Also, this is something called move the problem. The swap components approach is very elementary troubleshooting techniques, which is one of the most basic method which you don't have to have advanced knowledge and use for the problem isolation. It's not you physically swap components and observe whether the problem stays in place, move with the component, or disappears entirely. So this is a kind of simple method you can try if you don't have advanced information or more information, and just to start the troubleshooting approach process, can use swap component troubleshooting approach. So now we have 6 troubleshooting approaches. So you can go through the details and compare each troubleshooting approach and decide the use cases and understand the use cases for each troubleshooting approach, and it can be quite helpful to understand these approaches and compare and select the best approach in terms of your exact scenarios. So these are quite useful in terms of day jobs, your day-to-day work as well. We'll be discussing more details on the tools such as MTR, my-trace routing. So that will be done at the next stage within the next lessons. Okay, so that's about troubleshooting approaches. Now, are there any questions until this point? Just raise your hand or type the question on the chat. All right. Let's move ahead with the troubleshooting fundamentals. This goes to the deep level, but we'll start with the simple understanding and the definitions. Networks were always designed to do one thing. So that's carry the information from one attached system to another. Networks are designed to do one thing, which is information transfer from one system to another. Even that's mainly the information networks or information technology networks, but there can be other networks as well. Road networks. The road networks, you are transporting the vehicles to one place to another. The electricity network, you are transmitting power from one place to another. So their networks are usually in terms of transporting one place to another place. So that's simple. So that's the narrative here. So let's go into the more details in terms of definition. Network engineering works in a largely virtual space. Although there are wires and devices, protocols, data, and functionality are all laid on top of the physical infrastructure rather than being the physical infrastructure. So if somebody asks you to show the network, usually people show you the data center or the cables or the network devices or the things on the physical nature. But it's not the real definition. The definition wise, it's more of a virtual space, which is intangible. Those are the tangible ones we can show you physically, but network is something like virtual, something within the virtual space, which is imagination. For an example, let's give you an example. The previous troubleshooting methods, one of the troubleshooting tools I have been telling you that ping is an application. You are sending one ICMP message from source to the destination and you are getting a response, reply ICMP messages, and ping application provide you an output saying that this has successful ping and number of ping, the ping ICMP packet sent and received one as a reflection. So now we are thinking that network is working fine, but have you seen the packets transforming? Can you see even by using a microscope? Those are electrical signals. You can't see by your sense of organs. You are imagining and trusting the tool. This packet has reached the destination and responses. So it's a kind of you are just imagining things. You are assuming things based on the ping output, but you haven't seen it physically transporting. Likewise, you can see in the road networks that you can see the transport, the vehicles traveling from A to B, and those are physically observable. But in IT networks, this is mostly the virtual space. You are unable to see the electrical signals. You are just assuming this packet will go from A to B and B to C, and all those things are just assumptions. You are thinking in a virtual space. If you are a network engineer, even that's the case for the all IT engineers and staff, even the developers, they're thinking this packet will send here to the socket to the serial it will serialize from the network card and send to the first network device, and all those are imaginations. These are just assumptions we haven't seen by using our sense of organs. So that's basically a virtual space. So it is quite important to understand that aspect, even in the based on the troubleshooting fundamentals, because most of the things you can't physically observe. Just assume based on your intuitions and troubleshooting methods, the packets are transporting here to there and work according to the model. So all these things are model thinking. So that's one of the things. I assume that the IT is somebody has a question or something like that. Okay. Again, that's something important in terms of the systems. IT systems are operating based on the models, and those are on the virtual space. We are working on we're doing an imaginative work, which is difficult to tangibly prove this is existing and verify that. But we all agree to work on a model, and so it is important to while we are troubleshooting, it is to understand the modeling aspect of troubleshooting. And the network is a conceptual thing built using a wide array of individual components connected together through a protocol and data model. So network is a conceptual, as I mentioned, conceptual thing, but it's when you are seeing network is a collection of individual components rather than it's just one entity. You have bunch of individual components, and those components are agreed to work on certain protocols and data models. These are the ones actually running the network. These protocols and the data models are the ones, not the physical components. Physical components you can interconnect, but most important part is not the physical component, but the protocols and the data models running on these devices at the control plane and data plane. This means design choices are almost infinitely variable and malleable. This means your physical, even though you have similar physical devices, can have different protocols and data models running, and you can build new models, new protocols to communicate by using same physical devices. So control plane and data planes are more important in terms of troubleshooting aspects to understand this criteria. So these are basic fundamentals. Probably we haven't discussed on the previous courses, but it is the definition in terms of troubleshooting fundamentals to make all the fundamentals build on top of these axioms. Okay, this is about definition in terms of the fundamentals of troubleshooting. Any questions on this? Just raise your hand. Probably we can try it out. Any questions, or just type it out. Okay, this is another important point in terms of the troubleshooting aspect. The business-wise network risk management is one of the fundamentals we need to address in terms of troubleshooting. We are using, we need to manage the risk of failures on the network. Or somebody asked the question, right? Okay, no questions. All right, network risk management, basically in a real world, when you are managing a network, you need to avoid the risk of failures, risk of failure in terms of application, in terms of network, and in terms of other IT operations. So troubleshooting required when there is an issue or failure or trouble ticket. So managing the risk quite important or to reduce the number of issues. So that preventing is the best option rather than troubleshooting or the attending the issues. So even though this network troubleshooting course, we are discussing the issues after it's happened, it is important to reduce the risk of failure. So we don't need to troubleshoot at all. So the reducing the risk is important aspect. If you have a objective function from the your management to reduce the troubleshooting efforts or the impact of troubleshooting. So that's why we are discussing here in this particular segment. You can predict the amount of down up time the network will experience each year by statistical measures and analysis. So let's say you have your company or organization where you are working is having managed by objectives, and you are giving objectives for each employee, 5 or 6 objectives for each employee to achieve within the year. You are a network engineer. You got a business objective to achieve. Reduce the number of downtime, the downtime per year for this year, and you need to evaluate your network up or down time by statistical measures and analyze and give a report of the year end. So if you significantly reduce the downtime based on the statistical measures, your management will give you a bonus, so increase salary or give a promotion can be done. So it is important to measure your systems, even for your individual performance, as well as the reflect the decisions you are taking, logical decisions you are taking to reduce the downtime and enable the higher uptime. So maybe you can't make it zero, but reduction is a real advantage for the business and the operation of business functions and applications. And downtime and changes are facts of life of a network, and everybody knows that downtime, the higher downtime means you have unreliable network, and users are complaining, the business applications are not functioning well, and you need to attend those, and the clients are complaining. And for an example, if you're working for large bank, your online users are unable to transfer funds between the accounts, and your network is always down and getting more downtimes per week, and it's a 24/7 operations, and your senior management may consider that, and you need to find a way to reduce the downtime. And how to measure the uptime or the downtime is there are several ways. This is just an example. Uptime of individual network components can be measured. For an example, you can measure uptime for individual devices based on your records. If any given device in your network fails or changes 1 hour in every year, for an example, you need to down one of the particular devices, even there is no failure, or at least you need to restart once per year. So it requires downtime. So you can calculate uptime percentages per year. The per year means you have 24 hours per day and 365 days per year. So that's the total number of hours available for the year. So you can divide the total number of hours your uptime divided by total number of hours and make it percentage. Usually uptime percentage can calculated by reducing the downtime from the total hours and make it percentage. So that's how calculated. So for this is an example. If it is down, you are saying that this device will be down at least 1 hour with the failures and the restarting requirement, maintenance requirement. It'll aggregate downtime will be estimated for 1 hour. So you just need to reduce 1 hour, which is 365 into 24 minus 1 hour divided by total number of hours and make it percentage. So you can see that 99%, 98858% uptime. So this is a simple calculation. Everybody can do this. So this is how measure your any of your individual device or components uptime. If you have number of this may not be the only device available in a network. There may be ample number of devices. Let's say you have 100 devices of similar, and when number of devices increases in the network, then overall network downtime probability also goes high. Means uptime percentage of network will be decreasing. So you can't assume that, let's say you have a particular router model. Let's say you have a 4500 series Cisco router, and you calculated uptime with assuming 1 hour per with device, and you are presenting that to management that our network is 99.98858 up. Because the error you have done here, you haven't considered other 99 routers, because they can be go down parallelly as well. So you need to consider all the router downtime. So let's say if you reduce 1 hour per every router, then you need to reduce 100 hours from this. It is not the case most of the time. It is something in between. So it can be more than that as well. You need to take into account other devices as well, because network may be having multiple devices. You can't just multiply linearly to calculate all the downtimes by increasing number of devices. So that's where the scale matter. If you are increasing number of devices on your network, your downtime may increase heavily. So that's the important part in this case. For an example, this is one of example. The scale matter on the network risk management. Now we are discussing on the risk management. So to understand the risk of having large number of components, that is why important to have to use when you are designing a network to reduce the troubleshooting or the downtime, simplicity of troubleshooting. You need to minimize the number of devices, because each and every device has its own downtime. It's usually mentioned based on the test results by the vendor. For an example, as I previously mentioned, if you have taken to consider implementing Cisco 4500 router, that's on the device specifications with the availability numbers. So you can't just multiply based on number of routers purchased, but you need to study or find out that by using statistical methods and trouble methods and data collection, and based on the modeling, the risk modeling, I just wanted to highlight this perspective. Let's go into the scaling discussion on the scaling. The scale matter on the network risk management. If any given device in your network fails or changes once in every 5 years, that means, for an example, if you have taken a bulb, light bulb from a particular vendor, there is a usually warranty or lifetime mentions there, number of times you can on and off the light bulb. So that's tested and mentioned based on the statistical figure. So if it is 2 years warranty, usually you should expect it's not, it may work sometimes more than 2 years, but the company guarantees, the bulb manufacturer guaranteed only for 2 years. That's a bonus if it is working. If it has failed, you can get the replacement or warranty by that. Similarly, for the network devices, there are the matrices mentioned in the specifications for the failures, failure counts. You can, when you are selecting the devices, you need to check those specifications in terms of the failure counts, in terms of statistics they provided on the brochure or the spec sheets. Let's assume a linear regression for this explanation. So let's say your network failures or changes per year versus number of network devices in the network. So you can there is a serious correlation between number of devices and the failures. For an example, let's say you started your own startup company with the 50 routers or 50 network devices, and initially you noticed only couple the 40 to 60 failures. Let's say you started with 300 devices. Initially you noticed only 60 failures per year roughly, but suddenly you got a merger or another company merged, or your company scaled after 5 years, and the increased number of routers to 900 or 1000 routers. Now you are getting more failures within a year, which is around 2000 based on this example graph. So that's again, the network is one thing, you are getting more failures. So you need to increase number of network operational staff, and you need to find out scaling methods or enable the redundancy to failure, make it transparent on it impacting users. You may need to increase the monitoring, and you can't just increase number of devices as scaling. You need to work on the network risk management as well. Reduce the failures, even number of devices increased. So that's the concern here. So the major point you need to get understanding, increasing the number of devices, definitely increasing the failure points of your network. So it's impacting, let's say you are running 1 or 2 applications, it's impacting your applications, whatever the device failed, from out of 1000 devices, it's increasing. Adding more devices definitely increase the network failure points and failure occurrences. So you need to work on attending, reducing the failures while they are scaling. So that's called that's one of the aspect of network risk management in terms of scalability. So scaling is not something easy. Building a large network like Amazon, AWS, Facebook, LinkedIn is not easy procedure. So it's not something you are equivalent to building a home network or a small business enterprise network. So when you increase number of network devices, definitely failure points and failure occurrences increase, which you need to avoid considering network as a one thing or you are running. So there are several ways to address the scalability, increase scalability requirement, addressing with the risk management. And so you need to work on that. I can take another example as well. When scale increases, your risk of failure can be high as well. For an let's say comparing a cat versus an elephant. Cat is a small animal, and elephant is the largest in the land. But cat can drop down from trees, and it's quite capable of operating on living on the stresses. But how about the elephant? Can they? Elephant is not quite usually quite fragile in terms of their mobility, and they can't go on the walls, and the drop down can maybe catastrophic. So when things get scaled, not even networks, even in the nature, you are getting heavy risk, and you need to address the risk. Your network is growing. There are several ways to address this network risk in terms of availability. This is one of the aspects you need to keep in mind while scaling the network. Any questions on this? Network risk management is not just collecting statistics. You need to get interpreted and understanding in terms of, okay, just need to get interpreted in terms of getting understanding of your statistical data as well. You can collect data with several ways. This is an example, MRTG graph or PRTG graph in terms of bandwidth and the transfer bits. Usually it is configured by network engineers for the monitoring of bandwidth utilization to understand the patterns, and this is an example of daily. Usually in the night time or the morning time, you are getting not, your network may not be utilized that, but daytime you are getting peaks. But again, you are getting lower bandwidth utilization at the night and morning, early morning times. And we can get the weekly graphs. And these are the collection of bunch of statistics to get understand. But so in terms of example, you don't get on a plane with 95%. Another domain example. In terms of network, you can have take some risk, but there are situations you can get risk in terms of mission critical applications. For an example, let's say if you have a large stock exchange with ultra low latency network, and the few minutes downtime may lose millions of dollars. So there can be ones who are scheduling and booking this thing what's called airplanes, or there can be situations on the space missions. You need to have reliability in terms of your network designs as well as application designs. You didn't this is just another domain example. You didn't get on a plane with 95%. Let's say one of the airlines advertising that they have 95% confidence of safety, only 5% lagging. I'm not going to use that airline because when you are trialing more, you will definitely you will be losing your life, and the pilots may not even consider joining the airline, because some of the requirements, business requirements, usually the planes crash at least very rarely, and they reduce the risk tremendously by their processes. They handle the requirement over the years, and now very rare in terms of plane crashes. That's by their processors. Similarly, for the networks, now we have mission critical networks. We can down even half an hour. It will be tremendous loss of lives and maybe the wealth. So that's why we need to address this network risk management based on the modern demands and requirements. Risk of ruin must consider for business continuity. Risk of ruin means it's not just a risk of losing some amount of wealth, or but your business may entirely go down on certain issues. For an example, let's say you get a reputational damage and your business may entirely go down with the confidence, and your stocks may got crashed, and there may be business closure with certain times. If you are running a business with mission critical applications, for an example, let's say one of the one of the commercial banks, if they are keep on getting down and losing the confidence, and if it is down for 3 or 4 days, most of the online customers will be you will have to go to the ATM or the let's say the branches, and those are filled up or queued up. Probably it'll make confusion them, and there may be issues like database crashes if that affected somebody attack the network or bypass the network security. So it is important to have a secure risk manage on your network. It may be end of your business in one day if you haven't careful. I hope on the last year you heard that database extracted by external party and published on somewhere, and all the banking details published on the internet. So it's something like you are securing the network and managing the network risk is quite important. Sometimes it's the end of your business continuity. And then again, in terms of probability distribution of network performance measures must identify and map correctly, not always follow the bell curve, because this is one of the aspects we need to configure in terms of network risk management. There are people who are getting network traffic graphs and getting the standard deviation and asking a standard deviation and mean values and all those things. Those are related to normal distribution, which is the bell curve, and it's matter mostly the day-to-day life, like if you are measuring the height of the people and getting the distribution of that, it follows the normal distribution, which is the bell curve. And you can use those mean and standard deviation as the matrices there to measure the distribution, to understand the distribution. But in terms of networking, you don't see the bell curves everywhere. You may having different curves. In this case, there can be Pareto distributions or the different simple gamma distributions and fat tail, and those are extreme scale distributions. And you need to, if you have data, you need to map it to correct distribution for the analysis of matrices. Just don't assume that normal distribution is everywhere and following all the network stuff. So that's something else quite important in terms of your risk analysis. And no network is ever static. So networks are dynamic stuff, and the traffic pattern may change based on application requirements and how the application users responding. May be impossible to analyze without repetitions. The always is not repetitive. For an example, you can see the stock exchange really deviate, increasing the load when the President Trump making strange decisions. Suddenly stocks may go high and go low in terms of in terms of its behavior and the user perspectives and usages of your applications. And similarly, applications may change with the demands based on the external factors or sudden requirements. You need to plan the peaks as well, not only for the normal day-to-day network traffic on the normal day. You need to plan for the extremes in terms of network design. So that is important aspect of scaling and the risk management. Understanding the behavior of network devices, sometimes no clue about the collective networks. So people sometimes assume that you have understanding of how router works and how routing protocols work and all those things. Still, a collection of routers may have different collective behavior. For an example, the individual can have his individual own behavior or generic behavior. As a team of people may behave differently, even the same individual may behave differently when he's on a team or collection of people, because it's a team behavior can be different from the individual behavior. So you can't just assume that even if you know how network devices work individually, it's not reflecting more sometimes in terms of collective behavior. So there are several situations, several considerations you need to work when you are scaling a number of devices. So that's again emphasized with this fact. Right, any questions on this slide? This is quite complicated, but complicated aspect. Now, next time we will be discussing the network complexity aspect as well. But risk management, the fundamentals are coming under this in terms of network troubleshooting fundamentals. Okay, let's move to the another aspect of risk management. Maybe you are learning this first time, but it's quite important in terms of modern networks. This may not be, because now AI and machine learning is in the business now. Let's discuss the idea of anti-fragility, fragileness, robustness, and all those three different ideas and compare each other. There are three types of exposures related to the network risk management. We can define fragileness, robustness, and definitely define the fragileness. The fragile is poorly designed network suffers or breaks from the volatility. If your network is kind of a house of cards, which is a small stress can make it down and unavailable your applications, it's poorly designed. If somebody designs without understanding the design principles or design patterns of network, that can be a poorly designed network. It quite possible to fail most of the time and reduce the high reduced uptime, and your applications are not affecting that, and your business affecting because of application failures and most of the time. That's we call fragile network. The fragileness we can easily understand. We saying house of cards, and you can see that certain glass materials transferred by fragile fragile, but network should be built to reduce the fragileness. So the term we are using with the reduction of fragility is robustness. The fragileness I represented as house of cards. The robustness is something like this. If something failed, it should recover fast, recover to the previous state. For an example, if one of the routers failed in your network, you should have a backup router to take over the functionality within few seconds or half a minute period. So you take over the function. Redundancy to take over the functionality of any failed routers or failed network devices. So that's basically if something fails, it's recovering and enable the similar functionality. It's not improving on failures. It's just recovering and re-establishing the same function. So well-designed network unaffected by volatility, because if you have enabled enable resiliency or redundancy to take over the function by another component. This is the aim of today's network. Today we are designing networks to recover the failure, understanding to address single point of failure and having multiple devices and hand over the functions within a few seconds or few milliseconds, and recovering from the failures and to the previous state. But we are not benefiting from the failures. So that's an example of there is a mythical bird in Greek mythology. I think it's on Harry Potter movies as well. So it's this mythical bird is phoenix. What phoenix does is if you burn the phoenix or if you destroy the phoenix, it will reborn again. So virtually you can't kill it, it will recover fast. So it's a kind of a bird which is immortal. You can't kill it because it's again reborn after destroying it or killing it. There is virtually no killing. So that's the we are currently targeting on our network designs in terms of robustness. So we are making methods, or we are following the design principles to make it recover without killing the network or without allowing to kill the network entirely on a failure of devices or component. It will recover or reborn, refunction by another component taking over the functionality. All right, that's called robustness. So, but the another one is possible. The robustness is quite possible, and it's available along these years in terms of resiliency, and it's the normal day best practices in terms of our design. Now with this AI and machine learning, we have another term which we call anti-fragility. Anti-fragility means total opposite of anti-fragility. Previously, people thought that opposite of fragility is robustness, but it's not the case, because fragility, if you put a stress on the component, it will reduce the functionality of the system or functionality of the network. But robustness, what is this is it's recovering. The opposite of fragileness should be, which means anti-fragility. If you give a stress to the network or the component, it will recover, not only recover, it will stronger than before, right? It's kind of a, that's the opposite of real opposite of anti-fragility, not the robustness. So the future networks, the most people are now trying to build this kind of networks. These are the research and development going on. Even I'm trying as well. Future networks may design to become. There are ones I will show you on the next week. Developments. Future networks may design to become stronger and further stronger with the stresses. If there is a stress or downtime due to a particular reason, it will not only come back to the previous state, and it will learn from the failure and improve. Next time it will prone to that particular failure type, or it will increase further with the predictions. So that's possible with the machine learning and AI component integrated with the control plane of network devices these days. That's the opposite of fragileness. So I put up an example, another domain example again on a Greek mythology. That's again can be, I think it's on Harry Potter. You can Google it up on to understand these mythical creatures or animals. This Hydra is somewhat different from Phoenix, but Hydra is a large serpent, snake. So it has 3 heads or bunch of heads. So if you cut one of the heads to kill it, targeting to kill it, then you get two more heads on the same cut. So it's when you are stressing it, when you are cutting one head, you get 2 more heads from the wound. So how it's getting more heads when you are cutting the heads. So it may become more fierce than that. This is the idea in terms of anti-fragility on the future networks. The future network will be more prone to stressors, not only more prone to stressors, but still stronger with the learning based on the AI modeling. So it'll build immunity for more issues similar to this. What made it down? So these are the 3 concepts, 3 types of exposures in terms of network risk management: fragileness, robustness, anti-fragility. Okay, so these are the 3 ideas. Current day networks are mainly well-designed network are mainly the robust ones, or the future network will be more prone to not only robust to the stressors, but improve over the stressors in terms of the concept of anti-fragility by using the technologies such as machine learning and AI developments. Any questions on this? Okay, finally, this is another way of we discussed on the idea of risk of ruin. So risk of ruins basically represented here. The risk assessment is important. One of the way, the understanding this is you can see the quadrant here at left bottom. This is to understand the types of risk in terms of risk assessment portfolio. You can have the quadrant define the x-axis. You can have compact impact of the risk, and y-axis you can consider probability of occurrence. There can be a situation it may happen quite frequently or quite rarely happen. This can be categorized in the y-axis. Impact of the risk can be less harm or more harm. So this is the idea behind this on the quadrant. Identify. It is important to identify if you classify understand your probable risk or the risk you may face in future for your network or network design. You can categorize this for 4 quadrant. So the identify most probable and high impact risk, that is more important than other types. Okay, some risks might have enormous impact but are highly improbable. So those are the kind of risk we are calling black swan risk. Other risks have moderate impact but are highly probable and frequent. So let's go into the details. For an example, there are network related risk, which you know already, which is having low impact and which is having quite frequently low impact and high probable. For an example, let's say that is the bottom right quadrant section here, low impact, high probability. That is, we already know solutions because it's quite happening, and anything it's available always you can visible in any network, but impact is very low. So it's already known the industry already knows the solution, so you don't need to worry, and you just need to address those best practices which is available on the industry. For an example, there can be uh, cable breakdown issues. Most of the time, end users, the data centers are physically secured, nobody can go there, but the users having cable connectivity, most of the time at your desk connecting to your laptops or computers, but you know that there can be cable disconnection or cable fault issues, but that's affecting only that end user, because your servers connected through the fiber or something like that, it's well protected, nobody going there, and authorized people and can only visit, and cable issues are less and low. But your end users, it's quite pre-cut. They're breaking their cables or the connectors, and you need to get prepared with the additional cables. Just need to prepare. You are accepting that fact. Always end users can be getting these issues on the cables. After you troubleshoot, you can replace the cables. That's fine. It's addressable and it's easy. You just have best practices there, having quite a stock of cables and your stores to replace. Those are high probability. You don't need to worry very much in terms of network risk management or design there. But how about low impact, low probability? So that's again it's only let's say some of the users use a network cards of the laptops or the computers getting failed. That you know that you just have to replace network card, or you just have to provide alternative wireless access for them. If any network card fail, that's quite low probability, because rarely happen network card failures. And again, low impact as well, because it's rarely happen. Even though it's rarely happen, you can just give them a wireless access enablement, or replacement of card within few days, or keep few cards for you to have, or replace the laptop if it is taking the time to replace the card. That's quite possible to handle. So the bottom two quadrant sections are fine. And let's go to the high impact, high probability. There can be situations like high impact and high probability. For an example, let's say internet connections getting failed or diminished with the performance. It is quite usual, right? Even whatever the internet link you have taken, sometimes it's not functioning within the levels of expectations. It's quite probable. There is no way to, sometimes it's possible to have multiple links. It's impacting entire applications. But you can address that having a couple of connecting with two different service providers that we are discussing. For an example, your enterprise getting enterprise having critical applications which are deployed on the cloud, and you are if network connectivity, internet connectivity is quite critical for you. The one connection of internet to one service provider may impact you heavily on your business, and it's high impact, and it's quite high probable, because internet connections are usually it's a normal thing. It's degradation of performance or unavailability. It's high probable as well. But you can have another, there are well-known best practices and industry knows how to handle. You can have a couple of service providers connected with couple of routers and cables, and one side failed, other will take over the function, and you can load balance as well. And those solutions are available because it's high probable and everybody knows the solution, even though high impact can address that. The practices are available, but this can address by network design. But the most dangerous one is high impact, low probability, because it's rare. It's very rarely happen, but once it's happened, you get heavy impact and you are losing a lot, even the risk of ruin. Your entire company may out of business, because these are not very well known, frequent, well known to the industry, very rarely happen. And this can be the first time happen in the industry. The out of domain example, I can tell you that tsunami. We haven't heard about tsunami before, name of tsunami before that. Some of our 2000 years old history has some of some of the ideas, but we haven't heard experience it really. So after tsunami happened, it was a huge impact for the entire country, and there are 40,000 people dead by the impact. Now we are taking actions again if another tsunami comes. It's a rare event, low probability, but high impact. Those are the ones we need to consider in terms of there are ways to build network for unknown events or rare events. So that's one of the most important aspect while categorizing the different risk when you are designing the network in terms of risk assessment. All right, that's any questions on this particular slide or anything what we discussed? Okay, if you have questions, you may ask on the next week. When we are starting the session, probably we can introduce among us on the next week. Let me check this mic setup and the speaker setup on the next week and come back to you. And reference books on that session too on this, and next week we will be discussing the network complexity, and this including the risk network risk management as well, and the patterns in network architecture by John Day is another the useful book if further learning in terms of complexity handling or the network risk management. Again, the previous book which I mentioned by Russ White on the computer networking problems and solutions, chapter 1 will be useful. And troubleshooting and maintaining Cisco IP network is another industry best practice book, which is suitable for the examinations as well in terms of Cisco T-Shoot. And I'll be up. Somebody ask questions. Yes, still I haven't got the LMS account created. I contacted Mr. Tarindu, and probably he'll be creating once he created my account, because today is the first day. Even we scheduled this Zoom lectures on the yesterday. So once I finish, once I get the account for the LMS, I'll be uploading these 2 sessions as PDFs. If you have questions, you may ask on the next week. Let me know for anything else. Probably we can discuss in detail. And let's meet on the next week. Thank you very much for attending. If there are any questions, you can reach us, or I'll provide you email on the next week before the session. Probably we can discuss if there are any common questions. I can discuss in the class with the details. All right, thank you very much for joining for the first and second session. So probably we can start the third session on the next week. Thank you. Thanks again. See you guys.